Hello and welcome. Let me demonstrate how to write LaTeX code in Overleaf. To begin, you need to create an account on Overleaf. This is the interface of my Overleaf account. In the All Project section, you can see the works that I have created using LaTeX. If you want to create a new project, click on New Project, which will open a set of options in a new window. You can create a blank project, an example project, or upload an offline project, or even import from GitHub. Overleaf also offers several templates for your convenience. If you are writing a journal article, choose the corresponding template. If it is a book, choose the book template and so on. The thesis template is especially useful if you are planning to write a thesis. Click on View All to see all the available options Overleaf offers. Now I am going to click on Blank Project. You will need to give your project a name. Let me name it Sample and then press Create. Overleaf now creates the necessary environment for writing LaTeX code. Let me delete lines 2, 4, 5, 6 and 12 for now. What remains is the bare minimum required to start writing LaTeX. Let us inspect it. The code begins with \document class and then article within curly braces. Then we have \begin within curly braces document and \end within curly braces document. To go back to the main menu where your projects are listed, click the home icon at the top. Now click on sample to return to the project. On the left panel, you can see the main file main.tex. As our very first LaTeX task, we'll reproduce the text shown on the screen. Let us do it step by step. To write plain text in LaTeX, simply type it inside the document environment and press the Recompile button on the top right. You will now see the output on the preview panel. Let's now try to write equations. Equations in LaTeX are generally classified into two types. Inline equations that appear within the text and numbered equations that appear on separate lines and are automatically numbered. An example of an inline equation is the coefficient a subscript 0 and a subscript n and n greater than 0. Here, all are inline equations. Let's first write the inline equation. To write a subscript 0, use the command a_0 within $2 symbols. This is how we write the inline equation. Every inline equation has to be within the dollar symbols. Once I complete all inline equations, the output will look like this. Now let's write a numbered equation. Use the environment \begin equation within curly braces and \end equation within curly braces. To write a0 over 2, we'll write \frac a_0 within curly braces and then 2 within curly braces like this. This requires curly braces around both the numerator and the denominator. The first curly brace corresponds to the numerator in the equation and the second curly brace corresponds to the denominator in the equation. To write a summation, use the \sum command. You can specify the upper and lower limits as superscripts and subscripts. To write an integral, use the command \int. Let me now complete the equation and also add what is known as a label. A label is used to reference an equation later in the text. Equations does not need to be manually numbered. LaTeX does that automatically. Now let's write EQ2 and EQ3 as the labels of these equations. To refer to an equation in the text, write something like equation \ref and within curly braces write the label of the equation. Once we complete the code, the output will appear like this. So we have created our first LaTeX document. Now let me elaborate on the LaTeX environment. What you see on the screen is the basic LaTeX structure. It begins with \document class followed by an optional square bracket and a required curly brace. The square bracket is where you can define options like paper size, for example A4 paper, font size, for example 11 point, column style, example 1 column or 2 column. The curly brace is mandatory and contains the type of document. Common types include article, report, book, and letter. Article is for research papers. Report is for multi-chapter documents. Book is for books, and letter is for letters. Note that most science publishers like Springer, Elsewhere, IEEE, and ACM have their own predefined document classes. And if you are submitting an article to the IEEE journal, you can use the document class IEEE Tran. Below the document class and before begin document, it is customary to include use package commands. LaTeX by itself is basic, so we can use packages to add functionality like plugins. Some essential packages include AMS Math or AMS Simp for better math typesetting, graphics to include images, font spec or others to change the fonts. For example, we can specify Times or Helvetia, hyperref to create clickable links and references, natbib or biblatex for citations and references, geometry to adjust page margins, and fancy header to customize headers and footers. To insert mathematical symbols without memorizing codes, click the omega icon at the top. This opens a panel where you can click and insert symbols into your code. Explore tabs like arrows, operators, relations, and MISC to find what you need. Everything that we have done on Overleaf can also be done offline. For that, we have to first install TechLive, the LaTeX distribution. It can be downloaded from this site as a single ISO file. After that, we have to install a text editor. Download and install Text Studio from this web page. Once installed, open Text Studio and click Wizards and then Quick Start. This opens a setup window where you can change the document class. For example, article, report, letter, book, or beamer. Choose the font size 10 point, 11 point, or 12 point. Set paper size A4, B5, letter, legal, etc. Set language and other options. Choose layout, landscape, one-sided, two-sided, single or two-column. Click OK and Text Studio will create the default LaTeX environment. Paste your code and click the green Compile button. To preview the output, press the View button next to it. Text Studio has a pi symbol similar to omega in overleaf. Click it to access a wide range of math symbols categorized under operators, relations, Greek letters, and more. We have been discussing math input in LaTeX, and you can now see examples on the screen. As an exercise, I recommend that you try writing LaTeX code for the mathematical expressions shown on the screen. In this video, I introduced both online and offline methods of LaTeX coding. I also showed how to typeset mathematical equations in LaTeX. In the next video, we'll explore more about mathematical typesetting in detail.